Hi, my name is Peter Coker. I'm a software developer with Applied Computing and Engineering, and this is CMM Simulator. We've created this tool to provide coordinate measure machine simulation for customers who may be using programming tools that do not have simulation capability. In this example, I've connected to Holos, which is a Zeiss product, and we're communicating using Zeiss's CMMOS protocol. However, we can also talk to packages that use the I++ DME standard for communication. I'm going to get right into the simulation. You can see that I've created a work cell with a dual column machine and loaded indexable heads with multi-tip probes on each column. I'll zoom in here so you can see the tools. And I've also loaded a CAD model consisting of both side panels for a door. And in Holos, we've loaded the exact same models. I've got a measuring run that was created in Holos already loaded. And I'm going to go to the measure panel and automatically measure all the geometry. Now immediately you see our coordinate measuring machine going to the positions and measuring the points that are called out in the program. I'm holding down the Alt key right now on my keyboard, using a 3-button mouse to pan, zoom, and spin. And you can see that we're using both rubies at the end and sensors defined on the shaft of the tool. Here we're measuring a hemispherical plug in a threaded hole. And basically we're doing exactly what Holos is telling us to do. Holos, or any other piece of software that drives our simulation, does not have to be modified, as it simply is using the same commands and receiving the same responses that it would from the actual hardware. You can see here in Holos that once the program is complete, you see the results reported in green frames, meaning that everything's in spec. And I could go to Holos and start the measuring run all over. Once again, you'll see our machine drive to all the points that are called out in the program. I've got a speed slider so that while the estimated cycle time won't be affected, we can see our simulation simply speed up. So this, might be handy if you are reasonably sure of the program and need to operate a little bit more quickly. And there we see this brief measuring run is complete. We have a pendant that lets you control the columns of the machine just like you would with the real joysticks. I can move the X, Y, and Z axes. I can also switch into ABC mode here, which will control the A and B angles of the RDS indexable head. So as you can see, anything that can be done on the real machine is now in simulation, so that your actual hardware can stay in production while you're proving out your programs. We hope you've enjoyed the demonstration, and if you have more questions, simply contact Applied Computing and Engineering. Thanks for watching.